first for your information. So yesterday also we learned about the introduction to data entry and editing, and some of these components already being upgraded into the formulation using the Google Drive as one of the method to enter your data, so that you can minimize the error, you can standardize your answering, and so on. And then data entry also is very crucial, and you also conduct this data entry using the sheet. You remember the small sheet, the A4 size that I instruct you to enter, and then you successfully done it. Very good. So this is the data that already being done yesterday. And we also learned about reliability analysis. If you go back to your organization and you want to make some repetition and also some revision, you can refer to these notes where we have a lots of reliability tests. Particularly, we are interested into the number 4, which is the internal consistency reliability test, where we measure the consistency of the question, which is the question number 1 until question number 10, which is indicate the knowledge of the CPR yesterday story. And then we also being introduced about the inter-rater reliability between observer, and then the kappa statistic, the interpretation. So as I mentioned to you, some of the researchers suggest 0.7 and below is considered questionable, but some of them are considered acceptable agreement. So you can refer back to your statistical book, which one that you want to stand with. Test and retest, parallel form, and internal consistency, which is I already explained the Cronbach alpha before. Okay, so this is the interpretation actually. Less than 0.7 is actually acceptable. Less than 0.7 for Cronbach alpha is actually questionable, as I mentioned to you yesterday. And then we also learn about the introduction to data transformation. As you know, if you got data, don't worry if your data is in numerical form, but you need to translate into categorical form, because the SPSS will do it for you by using the recode. So we have two functions on the recode. Whether you want to recode in the different, we can see here, recode in the same variable, or you can use the recode in the different variables. In my opinion, please use the recode into different variables. Means that you did not change the original data set, okay, or the original value of your data. So this is how you want to compute. For example, you just give the instruction to the SPSS, then the SPSS will do it for you. This is the compute, for example. Of course, you cannot compute anything without data set. So let's say we open the data set of the CPR yesterday. I just want to make some repetition so that you have some idea. So this is the transform and compute, where we can compute almost anything. In yesterday discussion, we compute about the Y total, right? So the Y total is indicated by the sum of what variable. So you can just spell it out in the numeric expression here, or you can use the function group inside this particular box. You have a lots of function that you can instruct the SPSS to do it for you. It's either arithmetic or non-arithmetic. You can just type it. For example, if you're not sure, the sum that I mentioned to you, you can just type SUM, and then the SPSS give you some idea. The sum is actually return the sum of argument that have valid non-missing values. This function requires 2 or more argument, which must be numeric. Example, we will be like this. And then the sum, the question marks indicate that the argument that you want to inserted inside this particular box. So you can just insert it. And then the SPSS also already mentioned that minimum is 2 numeric expression, otherwise it's giving you the same thing. So this is the idea. Let's say you want to calculate the sum of y1 and y2. I would say y.exp, which is the y example, and then you can hit the OK button. Automatically, the SPSS are going to produce a new variable for you, which is indicated here. You see? Right? This is just example only. Okay, and then in the compute also, and yesterday discussion, we also learned about syntax, right? So the function of syntax is actually want to minimize the effort for you to use the GUI, guided user interface, which is analyze, descriptive, transform, recode, over and over again. Maybe you can simplify that one using the syntax functions. So the syntax functions are very useful, especially if you got a lots of data set. I took an example. So this is yesterday data that already being simplified. And all of this data and also discussion for this 2 days workshop is already being recorded into the syntax version. So this is our syntax, where the first step we make some changes because we got the negative what? Negative question, right? So negative question adjustment. We make some adjustment based on our negative question, and then we make some total count for our variables, and then we calculate also the mean, because sometimes some of you like the mean, some of you like the total, and then we make the total become categorical to justify the two groups, high group and low groups. And then we conduct some EDA, exploratory data analysis, for the frequency to examine the variables in terms of their minimum, maximum, in terms of their MCT and MD, measurement of central tendency and measurement of dispersion. And then we also conduct the frequency and also percentage for the nominal and ordinal scale data. Okay, and particularly some of you probably interested to identify and to understand the descriptive data that being collected based on each of the responses. Example kan, let's say you want to know Y1, Y2, Y3. What is the each individual story of each responses? So you can go to the analyze descriptive into the descriptive. Inside this descriptive, actually, you can go one by one question to see the mean of overall data as the individual answer. You see, this one, CPR for the question number 1, the mean is 2.12. So it's indicate that the level of the personnel that answered this particular question is around less than 3 lah, which is most of them are strongly disagree. And then CPR is for saving life. Most of them are actually in the midst of unsure or undecided, because it's 3.6 is 3 is neutral, right? 3.6 is some sort of very undisclosed argument, because you cannot say they agree also. Alright, that is the example if you want to analyze individually. Okay, in your EDA, exploratory data analysis. Okay, after the compute, we also learn about recode. Yesterday, I only discussed about high and low, but today I'm going to expose to you how you can make more than 2 categories. Let's say you want to classify your income into 3 categories. Less than 5,000, 5,000 to 10,000, and more than 10,000, for instance. So that one's required the use of the recode. So no problem. If you got very huge data set, 1 million, 1,000 or so, you can still use the recode to just in a split second change everything into the categorical form. That's why prioritize to collect your data in the numerical form rather than categorical form in the first place, unless you cannot do anything. For example, you want to measure death or not death. Of course, you cannot measure anything, right? But if you can measure some sort of numeric evidence to justify something, better you collect that one first, rather than you justify the illness or the diseases that already being impacted to your populations or your point of interest. And then this is the recode procedure. If you got any hang or any confusion, you can refer back to my notes, to our notes, and then you can follow accordingly the steps. Step number 1, step number 2, step number 3. So it's look like a book, but actually it's being simplified into versions of slides. So you can just follow through, and then you can just make an exercise if you forgot or if you want to make some extra knowledge. And inside this particular slides also, in the last part of our slides, we give and share also with you the example of the tables that suitably and important for you to project for your readers. Example like this lah. If you want to see the table 1, descriptive statistic or demographic background, this is the way of doing things. So if you want to do it, you can just follow it through. If you forgot how the steps to construct those tables, you can refer to our videos. And then the next one, you also learn about normality test. If you forgot about the normality test, no worries, because we also supply the notes. You can refer back to the notes. And generally speaking, we got 2 items to be considered: the statistical approaches, and then the next one is the graphical approach. So for the statistical approach, you can refer to the skewness, you can refer to the kurtosis, which is I already mentioned to you before. When you times by the times 2 for the standard error of the given skewness, you compare with the statistical skewness that already being reported in your SPSS. If you find out that your level of standard error times by 2 is much more higher as compared to your statistical skewness, that indicate the normality assumptions has been made. Okay, this is the example of the normality test using the Kolmogorov-Smirnov statistic and also Shapiro-Wilks. You also can use the graphical measures, namely as follows. normal QQ plot, detrended QQ plot. So remember, detrended QQ plot is talking about the dispersions of the data within the plus minus 0.3. So if you forgot, never mind, refer to our notes and then refer back. Oh, it's within 0.3. So that 0.3 is also being explained here. No worries. So you can just refer back to our notes if you got some argument with your colleague, or if you lost somewhere, you can just refer back to our notes. Okay, this is how we want to report your data based on the Kolmogorov-Smirnov statistics and also their p-values. Remember, Kolmogorov-Smirnov statistics and also Shapiro-Wilks probably useful for the data that's being collected, not very large data. But if you have a very huge data set, let's say 1,000, 2,000, probably this one is not a very good justification. You might interested to explain about the graphical measures rather than the Kolmogorov-Smirnov and Shapiro-Wilks. That one is based on my professional experience, okay? And then we also explain and also discuss about the introductions to frequency and basic statistics. So we learn about how to run the frequency. So the difference about the frequency, as I mentioned to you before, if you run the frequency, you can run it for anything. You can run it for the ruler form or for the categorical form. But if you request the ruler form, only you can click the statistics. If you able to call upon the gender, for instance, you never and cannot request for any statistical measures, because it will lead you to misinterpret your data. Because if you click the statistic button and then if you request the mean or standard deviations, that will be totally wrong. Why? Because the gender is in the categorical form, categorical data. So number 1 and number 2 indicated in the gender variables are no longer applicable for statistical measures. It's only tell the computer how many count of male, how many counts of female. So remember that. Only click the statistic radio button if your data inside this variable box are considered to be numerical data. Okay, remember that, Otherwise, you are already violating the functions of this particular software. Okay, for instance, you want to develop the charts, no problem on that also, because you can straight away request the chart, pie chart, or whatever chart that are relevant and suitable for your data set. That's why in the first beginning of our lecture yesterday, we learned about scale of measurement. So remember that 4 scale of measurement, namely as nominal, ordinal, interval, and ratio. So inside the basic statistic, we have all these functions. You can request for that. And then you have all these example and exercise. And you can actually use all these exercises based on what you enter yesterday. You remember you enter the job performance, job commitment, gender, age, whatsoever data that you enter based on the small sheets of the data, a piece of paper. So based on that data, actually all the training will be here. But in my presentation, I'm using the data that we collected lively from your responses, which is the CPR data set, right? Okay, and then the next one that we discussed yesterday is actually hypothesis testing. So for those maybe forgot what we discussed yesterday, we discussed actually 3 types of hypotheses that we are going to learn inside this workshop. The first one, hypothesis for differences, hypothesis for relationship, or we call it correlation, and hypothesis for modeling, which is under the regression. That one we try to cover during this today sessions. And then one more, we call it as the hypothesis for testing association using the chi-square for any non-matrix data, which is the categorical data lah. Sometimes you got the categorical data, right? And then you want to measure the associations. Therefore, you have to use the chi-square rather than the linear regression. And then you got the null hypothesis, you got type of hypothesis, step of hypothesis, step 1, step 2, step 3, step 4, and step number 5. And then you got these 2 types of error, type 1 error and type 2 error. So make sure that you are collecting your samples or data based on the adequate sample size measured. Otherwise, you have a tendency to make the type 1 error or type 2 error. Okay, this is type 1 error, type 2 error. You can read. If you want to know more, you can learn into the statistical book. Okay, this is general observation based on the story of my presentation yesterday about using the manual calculation to estimate the judgment of rejecting or fail to reject your null hypothesis. And then yesterday also we learned about t-test. One t-test is not yet being presented to you, which is we call it as the PET sample t-test. This PET sample t-test is not yet being explained to you today. So today we are trying our best to explain to you about the PET or dependent sample t-test. Independent sample we already learned yesterday. And then the concept is very simple. You got the null, you got the alternative, and then you set your alpha, and then you got the run. You need to run the values and report those statistical values, and then make decision and conclusion. So this is our steps, and this is the example. So we are going to use this example after this, okay? So bear in mind. I'm just going to make some quick revision first. And then we also learned about analysis of variance yesterday. Yesterday we learned about the ANOVA. So ANOVA is actually testing the differences. Same like independent sample to test, except ANOVA used for the independence group more than 2. Which is you find out that you have gender is independent sample to test, but races is more than 2 groups, therefore you have to use the ANOVA. So the ANOVA will be very, very simple, but you have certain assumptions that should be met. The first one, normally distributed, homogeneity of variance, and random samples. So inside this slide also, it's telling you how you want to justify whether the data can be further analyzed or not based on the post hoc analysis. And then you also have the 5-step hypothesis testings, and then you have this post hoc comparison, and usually we are going to use the Turkey HSD, honestly significant difference. So this is the example. So based on this particular example, you can do it yourself, you know, even though you will do it maybe 2000, you know, not now lah. I mean, you do it later on, right? But I'm very sure that you're not doing it after you go back to your organization, right? Maybe you do it in the 2028, maybe 2080. 2080, when you start to pension, then you try to recap back what you learned. It's okay, up to you. But if you want to do it, you can just do it yourself. I mean, DIY version, you can just put 3 groups, and then you justify the data based on this particular way of doing things, and then you can run it, and then you can make your judgment, and then compare with the notes that are given to you, so that you have the idea what is the statistical nature and how we are going to do about it, okay? And then we also learn about the post hoc analysis, right? So this is the way of doing the ANOVA or analysis of variance. So that is the simplified versions of my presentation today regarding the revisions of yesterday episode or yesterday discussions. So hopefully today we can continue more and more. And then if you got any questions, feel free to ask. Don't feel shy, and then don't feel afraid lah, because I'm not eating people, okay? I'm not a cannibalism. I'm eating the food, okay?